Today, we're going to talk about, we're going to keep talking about inheritance and methods. And in particular, there's an important um, thing to understand, which is how the Java virtual machine locates and executes a given method. And then the book uses this, and this is a common term, but I am not terribly fond of it. But since the book uses it, upcasting, and the concept is important though, just to kind of understand what's going on with that. Briefly talk about final variables and methods. You may have noticed that for some of the instance variables that we've defined, um, if you hover over the little light bulb to the left of the editor, it will sometimes say a certain variable can be made final, and that's when it's appropriate. That's usually a good idea. But it's important to understand what final means, and then I'll briefly talk about what class loading is about. Basically, that's how Java Virtual Machine figures out what classes it can use. Okay, so here's the thing, and this can be a little confusing. And it's important to distinguish between the compiler and the virtual machine. The compiler is much stricter than the virtual machine in the following sense. If you define a variable to be a particular type, and this applies to objects. So if I remember, a class is a type. So if I define a variable to be of a particular type, that's say a superclass of the one that I'm actually instantiating, then if I try to invoke a method that is in the subclass but not the superclass, the compiler will not let me do that. Again, this is an important thing to understand, where some of the red squigglies come from. If the compiler will not allow a method to be invoked in the subclass if the variable has been defined to be of the superclass type. So there's this kind of bifurcation. In other words, there's a declared type of the variable, and then there's the actual type of the instance of that variable. Time permitting, I hope to give you an example to illustrate that. So if it's made it past the compiler, then that means that there is a guarantee that that method can be invoked. In other words, the reason the compiler is so strict is because it guarantees the virtual machine that that method at least can be invoked. Now, of course, that doesn't guarantee that the program is free of errors, because there are runtime errors as well as compile errors. Again, what's the difference? Compile errors are the red squiggly. In a compile error, the program simply won't run. And this is different than what you may be used to. In non-compiled languages, like scripting languages that are interpreted, if there's a syntax error, they will typically allow you to run the program until it hits that syntax error, in which case it bombs out. The Java compiler will never let that happen. Okay, so back to the method. So when the virtual machine encounters a statement that says invoke this method on this object, it says, okay, it starts with the the particular class of the instance. So in other words, if I have declared well, think back to the pets. Remember, we had a pet and a subclass of a dog. So if I declare a variable to be of type pet, and I invoke a method that says maybe like get name, that was something in the pet class. So that will work. And what the virtual machine does is if I have an instance of a cat and I invoke get name, then the virtual machine will start with the cat and it'll say something like, all right, cat, I need your get name method. Now, in this case, the cat did not define a get name method. That was defined in the superclass of pet. So what does a virtual machine do? Well, it says, well, first of all, since the compiler let this run, that means that that this method exists. So it goes to the immediate superclass and says, do you have a get name? In this particular case, it does. It says, okay, pet has a get name, it invokes that one. In some cases, it may have to go all the way up to object. So let's say I have a number of classes, subclasses. It could be several layers deep, but none of them have overridden the toString method. Now, the toString method, as we've discussed, is defined in the class object, which is the granddaddy of all classes. So if I do something as simple as trying to print an instance of one of these subclasses, and again, remember, none of the classes have overridden toString, it'll go looking for toString in the first class and it won't find it. It'll go to the superclass, it won't find it. It'll go to the superclass of that, it won't find it. And finally it gets to object and there it is, and it'll execute the default toString for object. Okay, so that's the idea. In other words, what the virtual machine does is it climbs the inheritance tree until it finds the method. And again, the method is guaranteed to be found by the compiler by virtue of the strictness of the method is guaranteed to be found because of the strictness of the compiler. Okay, overridden methods. Now we've talked about this a number of times, but again, it bears repeating. And the thing to understand here is that every class has direct access. The key is direct access to the overridden method in the immediate superclass. And we call that by super.theMethod. And we saw an example of that in the poker deck class where the poker deck wanted to shuffle a deck, but then also set the index. The shuffling was done in the superclass. In the card deck, we'd already done that. So the programmer, virtue of laziness, says don't re-implement something that you've already done and works. So we were able to call in the poker deck super.shuffleDeck and then do the extra thing. But there's no direct access beyond. So if I were to subclass the poker deck, for example, and maybe have like a Texas Hold'em deck, it could access the shuffle deck of poker deck, but it could not directly access the shuffle deck of card deck because that's 2 layers up. So, and then the admonition is to design carefully. So if you're designing and kind of writing these subclasses, just keep in mind that you can only have access to the immediate superclass directly via this super thing. Okay, upcasting. So, and this is something that's it's important to kind of how should I say, this is a thing. Criterion it's a useful rule of thumb. I mean, it's not ironclad. But like in the pet business, see, so we had a class pet, if you remember. There was pet, and then there was a subclass. One of its subclasses was a dog. It's hard to, not Doug, dog. Okay, and then we had another subclass that was a cat. And now again, this is not necessarily an ironclad thing, but that looks more like wog than dog. Dog, come on. Is the is a relationship, again, it's kind of a rule of thumb, but is useful when you try to make sense of something. So a dog is a pet. Does that make sense? A cat is a pet. Does that make sense? In the context of this, it may. I mean, if we're talking about strays, then maybe they're not, or something else. So we got to keep in mind the context of that. So I noticed in the card program, there were some examples where player subclassed card deck. And so if you apply this, is a player a deck of cards, a card deck? And that kind of doesn't make sense. And so again, this isn't necessarily an ironclad thing, but if something really doesn't make sense like that, then it should be questioned. Okay, so the upclassing thing has to do with the fact that you can use a subclass instance where the superclass type is called for. So for example, if there was a method in another class, let's call it, say, my pets, and I had a method called groom, and notice the signature of groom is pet. Okay, the signature of groom is pet. And so that means when I invoke the groom method, I must give it an instance of a pet. So so here's a dog. Now I've defined a dog to be, I've defined it to be a dog, and I've instantiated it to be a dog. And the question is this call going to work? See, because now a dog is, the dog class is not the same class as the pet class. However, the dog class is a pet class. It's a subclass. Okay, so it's not the same class, but it is a subclass. So the upcasting has to do with this, is that if I call, in this case, groom, and pass it a dog, when it's expecting a pet, what the virtual machine will do is basically upcast it to a pet. It'll say, well, you're a dog, but a dog is a pet. And so whatever I'm doing to pets in here, I'll be able to do to a dog. And that's guaranteed. That's guaranteed because everything in pet is also in dog. Every public method in pet, which is all I could be invoking here, is going to be present in dog. And the same as a cat. If I had a cat, so let's say I instantiate a cat. And then this would be legitimate. I could invoke the groom method. On the cat. This is legitimate, again, for the same reason. It would say, all right, well, you're a cat, and I'm expecting a pet, But since a cat is a pet, I will upcast the cat to a pet. So that's what this upcasting is about.
Is it, sir, is it still is a dog still a dog here and a cat still a cat? Or is it actually change them to being a pet?
No, well, a dog is a dog, and a dog is a pet.
But I mean, it keeps the properties of being a dog. It
Absolutely,
doesn't bug out.
absolutely. See, once you create an object, then everything in that object is basically fixed. So by like in this method here, where it's expecting a pet, the only difference is that I can only do pet things to it. I can only do things that are defined in pet in this groom method. I can't do it. For example, remember dog had a bark. So I can't make this pet bark, and I can't make the cat meow because neither of those methods are in pet. I can do everything in pet, but none of this changes the identity of either the dog or the cat. In other words, objects do not change their identity when you kind of treat them as if they were a superclass type. One of the advantages of this idea is that, for example, I can define, if I define an array of pets, I can put dogs and cats and anything else that is a subclass of pet into that array. And it will work because they are all is a pet. If I don't have that capability, I have to have a separate array for dogs, a separate array for cats, a separate array for any other type of pet that I might want. And that kind of, in other words, so let's say I have like in my pets, I had an array of the pets. And so let's say at some point after this, I say, well, maybe I want to have hippos as a pet. So now I'm gonna have to do something if I add stuff. So let's say I now have a new class. I'll define a new class called hippo, but that will extend pet. And once I do that, then any instance of hippo can now be put onto this array of pets, because in this case, a hippo is a pet. Okay, so this is, you might be wondering, okay, why do this? This is partly why. In other words, this allows me to design things so that all of the common elements, all of the common things are put into some superclass, and I can still have specialized methods and variables in the subclass. But this allows me to do common things, and also lets me kind of store them in places that are common here. So here the common element is the pet class, and so I can store it in an array of pets and everybody's happy. Okay, final variables. Okay, so I don't know if you've noticed that sometimes the NetBeans suggests that you make a variable final. It's not always right about that, but sometimes it is. So what is a final variable? Well, a final variable, it can be an instance or a class variable. The final is actually well named, because a final variable can only be assigned a value once and only once. I can also use it as a modifier to a method. I can define a method to be final. We won't be doing that yet. I can also define a class to be final. And final has the same meaning in that. In other words, if I define a method to be final, then I cannot override it. It cannot be overridden. If I define a class to be final, it means I can't subclass that. There are a number of classes in Java that are like this. For example, we've been working with the string class. The string class is defined in Java to be final. What that means is you can't subclass string and do something else with it. That's just something you can't be done. And then, of course, in a final class, obviously all methods are final by default, because since I can't subclass it, I certainly can't override any method. Okay, so now this is just more for informational purposes to understand how what the Java virtual machine is doing. And the term is class loading. So when the virtual machine starts up, what it does is how does the virtual machine know where to go? The answer is it starts in a class that has a main method. And the main method has to be defined in exactly the way that we've been defining it. That is public static void main with an argument of an array of strings. So it starts there. So when you say to execute it, actually the first thing that it does is it loads that main class. And then as it encounters things in that main method, as it encounters classes, then it loads the classes in and it's a lazy manner, meaning that it doesn't load the class until it's first encountered by the virtual machine. In other words, if you're running the program and there's a particular class that isn't being used, the virtual machine doesn't even load it. And then all of a sudden it encounters what will happen. It'll encounter a variable that's been defined of a particular class. And when that happens, the first thing it does is it finds that class and it loads it. Now, can it be guaranteed to be loaded? And the answer is yes, because of the strictness of the compiler. In other words, if there's a class that can't be compiled or can't be found, the compiler will simply not let the program run. So when the Java virtual machine starts running, it has already been pre-guaranteed that every class that's used to define variables that it will encounter has been correctly defined and compiled. When I say correctly, I mean syntactically correctly, not necessarily logically correctly. Okay, so now what happens when a class is loaded? Well, first, what happens is all the static variables are defined. And one little gotcha on that is that they're actually defined in the order that they're listed in the source code. So that sometimes you have to be careful about that, because if you try to use a static variable in a previous static variable, then things kind of get flaky. I'm not sure if the compiler picks that up necessarily. It might. I think it didn't use to. Anyway, there's something called a static initializer. We haven't seen that, but it's like a static constructor. And again, we'll circle back to this if we need it, but it just for completeness, know that it's there. Then now, if it is a subclass, and actually everything is a subclass in a way, but in loading the main class, it has already done this. So in the very first class it encounters in the main class, it loads that class, but in loading that class, what it does is it first goes all the way up to the highest superclass, which is object. And then it descends through the class hierarchy in that order. In other words, for the main class, it's typically it just goes up to object. So object gets loaded and the main class gets loaded. So let's say when it encounters our dog before. Okay, so let's say the first time it encounters a dog, what it will do is it will, remember there's object all the way at the top here on. So here's a dog. So a dog is, okay, before it loads the class, it says, okay, you have what's your super class? Pet. Okay, I haven't loaded pet yet. What's its superclass? Object. Okay, I've loaded object. That's fine. So now it will go down and load pet, and then finally load the dog. When if that's already been done, when it encounters cat, it will then say, all right, cat, I haven't encountered you yet. What's your superclass pet? Okay, I've loaded pet already, so now I can go down and load cat. So that's, you know, just to understand what the virtual machine is doing on that. So when it loads a class, first it climbs the hierarchy all the way to the, until it encounters a class that it is already loaded. The first time that's going to be obviously going to be object. In many cases, other cases, that's also going to be object. And then it starts descending, meaning it loads the class below that, the class below that, and the class below that until it finally hits the one that was being asked. Okay, so that's all that I had in terms of actual material today, but I wanted to maybe show some examples of this. Okay, so let me start with the final thing. Okay, remember all the way back we had this single card kind of early on, and you know, so one of the things that I added, again, this wasn't expected at the time, but just to make the toString a little prettier, I added a public static final array of strings, which were the value names. So the final meant that this can't be changed. All right, so now notice here that in suit and value, NetBeans is suggesting that it can be final. And in this case, it actually can. And again, we didn't know about final back then, or at least you didn't. So that didn't necessarily make some sense. But if you look through the class, notice that there we have getter values, but no setter. The only set times that they're set are in the constructor. And so we absolutely can make these final. And we can, you know, okay, so by making them final, it just says, all right, once I make a card, its suit and its value cannot be changed.
Sure, but that's only final for each individual object, correct?
Correct. Yeah, no, that's you raised a very important point. This, it's final only for each individual card, not across the board. This, the static one, is because there's only one of them, that's final period. Okay, so there's only one of these for the whole class. There's one of these for every object. So defining it to be final doesn't mean that I only get one for everybody. It means that I get one for each individual instance of the card. Okay, I wanted to illustrate, so here is our cat and our dog and our pet. Let me illustrate this. And so let's say that I have, oops, private, Okay, so I have an instance variable that's my pets. Now notice NetBeans is okay. It says it's never read. There are two patterns to this. One is so I mean, how do you get stuff into an object? Well, there are kind of two ways. One way is to just pass it in somehow. So here I'm saying when I instantiate a my pets object, I have to tell it, I have to give it an array of pets here. And again, because this is like a setter, I clone the array. We will not encounter any cases in which you do not clone an array when it's being passed in. So always, in a case like this, always clone the array so you're not breaking encapsulation. Well, let's see. Did I have a, what did I have? Okay, so now for this, what I'm going to illustrate this is I'm going to add, this is a little different than what I had in the thing. I'm going to add an instance method, and this is, I'm going to violate my own rule, but this is just because I'm trying to give an example. Okay, so now what I'm doing is I'm defining in the pet class an instance method called groom. And so in the my pets, I'm going to okay, so what I'm doing here is I'm saying that, okay, for when I say groom everybody, I'm going to buzz down the array of pets and groom them. And this, notice the compiler lets me do this because groom is a method of pet. Now, the thing is that, oops, where are we here? I'll put it in here. So first, what I'm, let's make 5 of them. Oops. Oh, was it name and a breed or breed and name? I forget. Name and breed, all right. Name and Okay, so whenever you get those red squigglies, okay, so 1, 2, 3, well, how many did I make? 5? Well, let's make it 4. So, um, all right, so now we have an array of pets, and then okay, so what I'm doing is, notice what Groomall does. It just says, I don't care, see, because it's a pet, I don't care what instance you are. I'm just gonna do that. So notice that what happened was it just kind of, it went through and it just executed groom on each of these. Now, how did it find the groom method? So first it went to the first dog, and the virtual machine said, all right, dog, where's your groom method? It can't find it. So then it looks for the class above it, pet. And there's your groom method, I'll execute it. Now, and this is kind of, all right, here's, what does this refer to? Does this refer to a pet or a dog in that case? And the answer is, this refers to the dog. So even though this is executed in the superclass, this still points to the dog. Okay,
It points to the dog, but does the dog has the properties of pet right now? Is that, or in this case, it has the properties of dog as well?
well, this it refers to the dog, and then notice that even though it was executed here, well, I'll tell you what, just to kind of let's see, okay, yeah, this see, well, a dog is also a pet, but this here, because it's in the pet class, you can't execute anything, any method in here. But when this is executed, this reference actually refers to the dog instance. And the reason sort of to prove that is that every time this was executed, what it did was it invoked the toString method of, well, in this case, it executed the toString. It tried to execute the toString of dog. Yeah, in fact, it executed the toString of dog. You see? You see that? This did not execute this toString because it added this large, which was only in the dog toString. So that proves that this here referred to the dog. And so this is what I'm saying with the virtual machine. When it tried to print this, it said, all right, what is the object? What is that object? And the answer in the first case, it's a dog. And so does dog have a toString? It sure does. And it executes that. And later, where it encounters the toString for a cat, it encounters the cat one. Okay. Okay. Okay, that's actually all I have for today. So is anybody going to complain about getting their money back if I let you go early?
I don't fully understand the in the test main class. I didn't see you call two string at all. Could you walk me through how it automatically does that?
Ah, okay, yeah. That has to do with what the virtual machine does is whenever you use an object where a string would normally be used, like when you print an object, what it does is it invokes the toString of that object. So where are you? Okay, so here it was printing this object, and whenever you print an object, then it invokes the toString of that object. That's just what it does. Okay, I mean, that's really all there is to that.
That makes sense. I forgot that there's a system.out print line not in the test.
Yeah,
But
yeah,
that makes
and again, I'm violating my own rules here just to illustrate a point, because normally you should not put print lines in your component classes. The print line should only be in the main. But the alternative would have, I mean, I'd have to write a whole bunch of other code to kind of just make a very small point. So, okay.
that makes sense. Thank you.
All right. Okay, so that's it for today, and I will see you tomorrow.